This video is going to cover simplifying square roots for my early college math students. If you are not in early college but you're watching this video, it might help you more so than the way that I taught you first. So if you are in early college, this is the way that we talked about it in class. Remember, there's another video that gives a different way to do it. So how did we do this in class? Okay. Well, first off, let's again, what is a square root? So remember, square roots are a number times a number equals the number that's inside. So for instance, if I have the square root of a times a, so a is anything, could be 12, could be 15, it could be a decimal as 2.5. And I take the square root of whatever that is being multiplied, I get just the value of a. So an example of this would be the square root of 3 times the square root of 3 is actually the square root of 9. But what is the square root of 9? That's just 3. So you can see if I break it down into two parts, one of them just comes out. And this is what we're going to utilize during this method. So when we simplify square roots, that's what I want to do. I want to do what we call prime factorization. This is what we call factor trees, but the proper mathematical term is prime factorization. Factor trees is kind of a dumbed down approach, but if it's something you remember, then that's fine. I'm just not going to refer it that way. So what I want to do is I want to take the number 200, okay, and I want to break it down into its prime factors. So I always try to start with the smallest number and go up. So I'm going to start with 2. 2 times what? 2 times 100. Then, because 2 is now prime, we can stop there. The 100 is 2 times 50. Again, 2 is prime, so I can stop there. 50 is 2 times 25. Again, 2 is prime, I can stop. And then 25 is 5 times 5. Both of these 5s are prime, so I can now stop. And because my prime factorization of 200 has all of my prime numbers at the bottom of each kind of tree, right, branch, then I can stop and I am done. So what I want to do is I want to write those numbers out. So the square root of 200 is actually equal to the square root of 2 times 2 times 2, or I have 3 of them, times 5 times 5. What I'm then going to do is look at pairs. Remember, square root, we deal with pairs. So the square root of 3 times 3 is 3. So the square root of 2 times 2, what happens is one of the numbers comes outside, just like this 3 came outside, and then the pair of number, or the second number that's paired up with it, it just kind of gets forgotten about. Okay, I kind of use it in class saying, it throws in the trash. Like, it doesn't matter. That number is no longer important because the square root takes care of that. So then I look to see if I have any more pairs. This 2, I don't have another pair. But this 5, I do. I have 2 of them. So I'm going to take one of them out. And then the other one, again, I'm just going to get rid of it. It doesn't matter. It's no longer important. So what happens are the 2 numbers that were multiplied together in red come out front and be multiplied together. So 10. Then I have the root that's left. And then what number is not circled or crossed out inside? Well, it's this 2 that I talked about, so it has to go inside the root. It didn't have any friends. Think about it that way. It didn't have any friends, so it can't go out front and play, or it can't go outside and play. It has to stay inside. Let's look at this one, square root of 70. Again, I want to prime factor it. So 70, prime factor, 2, 35, 5, and 7. That is prime, prime, and prime. So square root of 70 is 2 times 5 times 7. Remember the last problem. I needed pairs of numbers. If it wasn't a pair, it couldn't go out and play. There's no pair to the 2, there's no pair to the 5, and there's no pair to the 7. Therefore, all I do is remultiply, and my answer stays what I started with. I didn't have any friends, so I couldn't go out and play. So I had to stay inside with all the other numbers that didn't have any friends. Oh, we got a negative now. This is a little complicated. It really isn't, okay? So remember in complex numbers that the square root of a negative, right, we talked about it, could be an I. So the square root of negative 63 breaks down into the negative 1 times the square root of 63. So then I have to prime factor 63. So I get 7 times 9, which is then 3 times 3. All of these numbers are prime. I can stop because they're at the bottom of each branch. So what happens is I now can rewrite this as negative 1 times 3 times 3 times 7. Look at pairs. I have a pair of 3's, so what I can do is I can take one of them out and I can cross the other one out. Kind of forget about it. Well, then what happened? Okay, here's how we get our final answer. So that 3 that came out is out front. The numbers that I didn't touch stay inside. But if you recall from complex numbers, the square root of negative 1 stands for something. What does it stand for? It stands for the letter I. So that I automatically pops out front. Whenever you have a negative 1 or a negative inside a root, it pops out and it's already an I. Okay, we don't have negatives inside anymore. Now we have I's out front. Well, this 7 didn't have any friends, so he has to stay inside. He can't go out and play. Let's look at this problem. Square root of 48. Again, I want to prime factor 48. Well, 48 is 2 times 24. 2 is prime. 2 times 12. 2 is prime. 2 times 6. 2 is prime. 2 times 3. 2 is prime. 3 is prime. Again, at the end of my branches, I am done. So I can rewrite it as the square root of 2 times 2 times 2 times 2 times 3. It's a lot of 2's. Again, I look in pairs. I have a pair of 2's there, but I also have another pair of 2's. This 3 at the end, there's no pairs. There's no friends with it, so it's got to stay inside. So we know my answer is going to be square root of 3 on the inside. Now I have to determine what comes outside. Well, because the first set of 2's has a friend, they have a pair, one of them comes out while the other one kind of gets forgotten. I don't know if he loses his way outside or what happens. He gets, I don't know, locked in a room. I don't know, but he doesn't come out and play. So then the other pair, this 2 can also come out and play. While his friend, again, don't know what happens. He gets lost. I don't know. Maybe he needs Google Maps or something. I don't know. What happens? Well, the 2's that were multiplied together, that came out in red, get multiplied, become 4. And I'm done. Because the 3 that didn't have any friends stayed inside. The 2's that came out, because they had friends, got multiplied together to become 4. This is the last problem we will do on this particular video. So 810, I got to prime factor it. 810. 2 times 4, 5. 3 times 1, 35. 2 is prime here. The 3 is now prime there. This is now a 3 times 45. So again, the 3 is prime. 45 is 3 times 15. 3 is prime. 15 is 3 times 5. 3 is prime. 5 is prime. I am done. So I can rewrite 810 as 2 times 3 times 3 times 3 times 3 times 5. A lot of 3's in this one. So now I look at what has pairs. I have a pair of 3's and another pair of 3's. So the first set of 3's, I can take one of them out and the other one gets crossed out again. He got lost. Then the second set of 3's, I can pull one out and the other one gets lost. So the 3's that get multiplied, or that come out, that are circled in green, come out as a 9. 3 times 3 is 9. What happens then? I'm left with the square root. This 2 didn't have any friends, neither did the 5. So because they don't have any friends, they have to stay inside. Well, what do they make when they stay inside? They make a 10, because 2 times 5 is 10. So this is my answer for this one. This concludes the simplifying square roots by prime factorization. So again, if you were in early college, this is the way that we did it in class. If you were in my honors classroom, we did not do it this way. You can still do it this way. It's still right. Just make sure that you know that this is not the same way we did in class.